Guys, today I'm going to talk about natural language processing, machine learning reviews. So what I'm going to do is I'm going to grab a large data set from Kaggle. We're going to take that data set and then do sentimental analysis. We're going to see if the review is bad or if the review is good. So I have gone here and added the database or the data sets in my Databricks website. So what this Databricks is about, it just like acts like an IDE. If you're familiar with big data, you know you have to have install like certain frameworks like Apache Spark, and Scala or Java, whatever language you prefer to choose. I mean, just it just saves a lot of time because you don't need to install anything. It just like you can like start right away with all the prereqs or languages pre-installed on this website already, right? So whatever data set you have, you can just like, upload in this data set. For now, I'm just gonna like quickly go over what my project is about and what we do, and then in the future, if you like to add me or go in depth, like step by step, I can do that as well. It's not a problem. Please let me know in the comments if you need more details of this project. I can go ahead and add all the script, the data set itself, and all the more details, right? So this was a group project done by me and two other friends. First, okay, let me start with this. This is going to be a machine learning project, right? So we have a big data set. The data set is really big. It's almost like 1.6 gigabyte. As you can see here, 1.6 gigabyte, it has more than 2 million reviews. So on the base of that reviews, we're going to classify if the review is good or if the review is bad. So there are only two classes. One is the label, which is going to say if the review is bad or review is good, and the other one is just the review itself, right? Now, and we're gonna like take that review and we have to do certain text processing. It's like we have the review could be in bad format, right? There are a lot of things that we don't want, and our machine learning algorithm may not want those kind of unstructured content in the review, right? So we have to like pre-process the text, also called natural language processing. We have certain techniques for that, and we pre-process the text, we clean the data set, and then we like pass feed into a machine learning algorithm, and we evaluate the results, like how much accuracy we get, how much the accurate is our new data in terms of the one we already had, right? So and the algorithm we use to evaluate our certainty are logistic regression, naive Bayes, and support vector machines. So we're going to take these three algorithms and then see what our results will look like, right? So first, text processing or natural language processing, and then we're going to feed that to a data set. A machine learning algorithm called logistic regression, naive Bayes, and support vector machines, and we're going to see the results, all right? It might be a little confusing because a lot of people are used in R or Python and not used to framework like this. This is big data. When the data set is really huge, it's hard to process using like traditional frameworks like R or Python. You know, you can still do this in R and Python using Apache Spark, but this is the easiest way to do it. So the programming language I'm using right now is Scala, and the framework is Apache Spark. That just like does the in-memory processing. That does all the processing like super fast. So just for now, if you are new to Apache Spark, all the computation is done in like seconds. It's just very quick, right? Um, so these are just I'm just gonna go over this very quickly. All right, if you don't get it, just let me know in the comments and I'll like post more in-depth content for this. All right, so these are all the like imports for Apache Spark and Scala. Now, so we're gonna load the table, right? So we're gonna load the data set. So what this line does is it's gonna load the data set. Because I've already loaded this already in the Databricks, I'm gonna like just refer back to the table that's in the Databricks, right? So file store table, big data set, the CSV is the location of the storage, right? And now the first column is label and the second column is text. So we're basically just loading it, and this is the review, or this is the original data set that we're gonna like perform our natural language processing and machine learning on, right? And then we have to, because we don't, this is really messy. Look, label 2 is bad and label one is good, right? So we don't want this kind of messy data. I want to make it look nice, right? So we're gonna create a column called label, and we can override this the old one and make it 1 and 0 for each one. So what this code does is it's just gonna like make label 2 is 1 and label 1 is 0. So we have a nice looking table right there, label and text. Now we want to do some like basic text processing. We don't want punctuations, we don't want like quotation, we don't want smileys on our review, right? So I'm gonna remove everything but words. So see right here the difference between this one and this one. Right here there is a quotation, right? And then on here we don't have anything, right? So this is just like basic text processing. We're just getting rid of the unwanted content from the text. Now don't worry about this one. This is just like just making some just words. Now let's go back here to the heart of the project. So how natural language processing works, or the text processing basically works, is like you have to have certain techniques to do, right? So what tokenizer does is it takes the review text and then separate it word by word. So if you read this sentence, let's say the heart of this project, right? So what it's gonna do, it's gonna take each word and put it into an array. The heart of this project. Just gonna like take word by word, and it's just easier to do computation. That's it. And then what this remover does, it's just gonna takes care of the unwanted words. Let's say we don't want the, on, and it just like creates redundancy, and we don't want those kind of data in our review, right? So we're gonna get rid of like on the like basic simple words less than 3 length or whatever, right? So and this is not useful for our project, right? We want something useful, because the review could be like great, good, awesome. Those are the type of the good reviews, right? On, the, off, they don't even make sense. So we're just getting rid of those online words. If you want to remove something else, you can just like go ahead and write another function and add into a remover. So the hash in TF just makes another column called raw features. So this is how big data works, like in terms of this particular project, right? So basically, I'll just go you and show you like how all this is working, and you will be very clear. It might not be very intuitive at this moment because this is just like a lot of code and a lot of new things. But I'll go in and explain a little bit more when we get at the bottom. So these are just the 4 things that we must have in order to like process this text, right? Now we're going to make a regression model for this, right? So this column, it's making a logistic regression model for our project. And this content right here, this is like, if you know about logistic regression, you have to because it's a classification project, you have to specify a certain threshold. If the probability of something is above 0.5, it's just going to be yes, and if it's below than 0.5, it's just going to be no, right? And this is all about the threshold. It's on you, like how much you want to put it, but 0.50 is the like general thumb to put it there. And this is regular parameter, right? And 0.01 is just I put it at 0.01. There are certain things that you should know about this one. For now, just remember the parameter is set up to 0.01, right? If you play around with this, you might get better results, or you might get less results. You just have to play around with this, or you have to study more. This is more in-depth content. And we're trying naive Bayes and linear support vector machines to predict our data set, right? But for now, I haven't done anything. I haven't used my data set. I haven't used my training data. I haven't used my test data. I haven't done anything. I'm just like initializing all the functions that I want. Later on, I'm just going to make a pipeline. What this does is it's going to take each of the functions or each of the variables, right? And it's going to like loop through each of them. And it will be more intuitive when I go further down. So I have my training data right here. So I'm going to call that model, right? Now, what this pipeline does is it's going to take the training data. Where is my training data? Training data. So I have created my data right here. I have split the data set by 90 and 10, right? So I have training and test data from this data set right there. So I have labeled this as clean data. I'm gonna take that data and then I'm gonna like make it 90% and 10%. So right, so training and test, and I'm gonna take that training data set and I'm gonna make a model out of it. Right now I'm gonna pass it to a pipeline. This is the pipeline. Now the training data set goes to tokenizer, it goes to a remover, it goes to hashing TF, IDR, and so on, whatever you pass it here, right? So it's going to go through each of these functions or each of these steps, and it's going to perform like certain operations that you want for our project, right? And then so does for the test, and now we're going to do prediction, right? Now, let me zoom out a little bit. Now, what I was trying to say is first we created a text, then we created words. As you can see here, this comma, we're getting rid of like the unwanted content of it, right? And we filtered it even more. Then we have raw features, right? So this is like basic uh, behind the curtain computation of how this Apache Spark works behind the scene. And then we have features, and then we have our prediction, and then we get the probability, right? For now, just remember, just like know the step by step. Now, first we have a label, we have the text, and we convert it to words. We convert it to filtered and raw features, and raw prediction, and we get the probability and we get the prediction, right? And this is our what our prediction looks like. 0 0, and there are like one is supposed to be 0, but it's 1. That's why this may not be able to get like 100% accuracy. Could might end up like 80%, right? Now let's check how accurate is our model is, right? And then we have a evaluator function. It just does the binary classification evaluator, and then we set the metric as area under RC. Area under RC is the evaluation metric to check how accurate our model is, right? And then we run this model and we get certain accuracy, right? Over here, if you go down, when I print it, our accuracy is 82%. Over here, our RC curve gives us 89%, but our precision and recall give us like 82%. So for now, our let's take this metric. Our model logistic regression 89% accurate. Now when we go down here, this is like basic other metric used to evaluate our performance for the model. You don't have to worry about this. And then if we go down right here, we're taking model 2 now. Model 2 is naive based, and we're going to do the same operations. Just take the training data and pass it to the pipeline, tokenize it, IDF, hashing TF, and all that sort of things that we done in the previous step. And we test the model, and we pass the test data set to test the model, right? And then again we find out accuracy for naive base. um, let's see, our model was 82% correct, not bad. Naive base is just used to compare all the models. It doesn't usually, it's not taken as the model to evaluate, but it's just considered the baseline of all the other models for classification. And when you go to support vector machines, it gave us 91%. I already ran this model. It just takes a while. Support vector machines is very expensive to run, so it just takes a while. So I did this before making this video. So our model is 91% accurate for this specific. And all these other functions that I'm doing right now, it's just like tuning the parameters, getting the best results out of it. When I tune the parameters, I get 93%. Right, accurate. So there are certain things that you have to work on to make the model more correct. So I was just trying to show you like the basic steps how to do sentimental analysis in big data. Like when you have a very large data set, it's hard to do in Python, like just the raw Python or R. And when you have Apache Spark, when you're doing in Apache Spark, it's really easy and really easy actually, like when you understand the framework itself, and when you have a good knowledge on like Python or Scala or R. If you have any questions or concerns, just like put it on comments, and then I'll post the script and like in detail, like what it means to write this code, or line by line. I'll just explain line by line. Okay. Thank you so much.